The last few videos, I haven't really talked about my cat, so I kind of made a deal. Yes, I'm talking about you. I'll make sure to bring it up. Last week, we looked at modules as black boxes. Essentially, we had to take as an article of faith that the methods worked the way that a table or I told you they worked. This week, we're going to look at modules and objects that we write ourselves from scratch and understand why we might do that and how it makes our lives easier. First, we need to make a distinction. We need to understand what I mean when I say module and object. We so far have been bringing in modules by importing them. And when we import something, we are essentially just getting raw inert code. It doesn't do anything for us the minute we import it. We have to use it in a program. And we've seen various ways to use objects. However, until we actually instantiate an object, that is, create the object or assign the object, we're not really able to use it as a fully true object. In our example here, we're going to import cat. We're actually going to build cat this week. When I import cat, I'm bringing in template code. Again, that inert code that constitutes what a cat should be in my program. But until I instantiate it, or until I create it or assign it, I don't actually get a cat. I can't actually act upon it or be acted upon by the cat. And this is our instantiation assignment creation statement. Cat equals upper cat parens. You'll notice a few familiar things here. First of all, we have a variable name, we have the assignment operator, and we have something that looks vaguely like a function or a method itself. So these are all familiar, but I want to focus mostly on the cat parens over on the right side of the assignment statement. Here, this looks a lot like functions or methods, so things we've used before, but gives us some insight into what we're going to be doing this week, which is working with functions to understand how we can stretch our understanding of them in order to create objects that are useful to us when we bring them to other programs. So this week bears some quick discussion about what I mean when I say the word object. So far in this course, I've referred to objects like dictionaries, lists, and strings. Those are just some of our examples. However, this week, when we talk about objects, we're really talking about things that have properties and methods that come from outside of our main programs. So properties we can think of as characteristics. Things of like a cat, for example, who has a name, has a fur color, has a pattern, but also can do things like can meow, and we can also feed or we could talk to our cat. So those are things that we definitely can do with the object, to the object, but they come from outside of our program. And we're going to see why that's helpful, because it allows us to differentiate one cat from another cat, because we could technically have multiple cats. I mean, no, man, I'm not even like thinking about another cat. Like what's a cat even? Like what's a cat? I don't think you bought it. Just like last week, I've given you some files, namely cat.py and catsandbox.py. Follow along using these files this week as we work across our videos like we did last week on a single program that's going to teach us some immutable laws about cats. We're going to be working in our cat.py file first, as you can see on my screen, so head on over there if you're not there yet while I'm talking. We're going to be working to build a very simple cat that has just a few properties, some characteristics of the cat. Then we're going to work on bringing it over to our other program so we can learn how to use modules as objects in just a little bit. But the first thing we need to do is we actually need to create some cat content. So in order to create my object, I have to classify it. I have to give it some kind of name so that I know when I'm calling a cat, that's what I'm getting. We're going to use a different keyword here. We're going to use the keyword class to denote that we are creating a classification that we call, and I'm going to use uppercase cat here in order to do so. So all we're really doing here is creating, again, a classification, a space for something called a cat. It doesn't exactly work as a function, but the next thing does. And this is what's referred to as a magic method. And in Python, you will see magic methods bordered by 2 underscores on either side. Now, what I'm about to make here is something called the constructor. And the constructor is the function that gets called immediately when I try to create the object in my other program. So if I import this, it doesn't get called. The minute I set up that cat equals cat parens, this gets called. And we're actually going to fill those parentheses in with something. And we'll see why. To create my constructor, I create it just like I create a normal function. I use the def keyword, 2 underscores, the word init or init for initialize. You can think of it that way, but this is called the constructor formally. I'm going to use one parameter called self, which we'll get to in just a minute. It's a bit different than the others. My three features that I want to give my cat, which is name, fur color, and I also want to give it a pattern. Now this self thing, let's tackle that really quick. Every object has the ability to remember things about itself. I call it self-knowledge. So for example, if we had two cats in the same program, we would want them to be able to remember their own names. We would want them to be able to remember their own fur color and their own pattern. So here, we need to use the self-knowledge to our advantage. And this is going to allow us to store some of these various parameters we passed in. So we're going to give it a name, a fur color, and a pattern when we create the object, but we're going to use that self-knowledge in order to keep it with the object while our program is running. Now, in order to add things to self-knowledge, we have to use self-dot. So the dot operator comes back in here. And I'm going to create self.name gets the value of name, self.fur color gets the value of fur color, and self.pattern gets the value of pattern. Now, these are different variables. Self.name, self.fur color, and self.pattern belong to this cat, and only this cat. Everything on the right-hand side, those are just parameters that we passed into it when we created it. But that self-knowledge on the left-hand side is what allows us to create objects that remember their characteristics. And we'll see that when we call this particular object in our other program, we don't pass self. Self is just assumed. We assume that this thing has knowledge about itself. But we want to be able to characterize that knowledge by giving it these parameters and then setting up these properties in our program for us to be able just to assign them so that our cats can be distinct and different. And we'll see that in just a second. And we don't have cats quite yet. It's a module, so we need to import it, but our import is going to look just a bit different than it did for our JSON and our random. If we look at our file, it's called cat.py. We know that much. But if we go into the cat.py file, we see we have this thing called class cat. Because we've created a classification, we've created a specific callout for just the cat here. We could create dog, we could create rat, we could create all sorts of animals here, but that wouldn't be true to our cat.py name. And of course, all we really want to talk about are cats. We know that. We need to do just a bit different of an import. And we're going to learn a different keyword called from. So from the file cat, we don't need to use the .py. Python's going to assume that we want to use that .py here. So this is just the file name minus the .py. From cat, so from file, import the classification that we want, which is cat. We want to get the classification that we created for cat. And when we drop down to main, we actually now have cats. We're going to create three. We're going to create Bert, Scoop, and of course, last but not least, our good main man, the boss. So to create Bert, I'm just going to create a variable called Bert and make it a cat. We're going to call it by name. It's a cat. We're going to give it the three parameters that it needs in order, which are name, fur color, and pattern. Now, Bert is an orange tabby cat. So Bert, name, orange, fur color, tabby, pattern. Scoop is a cat named Scoop. They're black and white, and they are calico in a way. The last one is boss, our main man. Cat Ulysses is a brown. We know that well. Mackerel cat. That mackerel striping is extremely important here. So he is a brown mackerel cat. And I'm going to prove to ourselves that we at least just have one cat. So I'm going to print out f string. Of course, I have to go with the boss. Boss.name, because if we're going to use that self-knowledge, we're going to say boss.the self-knowledge we want to use. If we go back over to our cat.py file, we see we have three self-knowledges here, name, fur color, and pattern. So you can imagine the object putting itself in the place of the word self here. So we can use boss.name is a boss.fur color, boss.pattern, cat. And if we get our syntax right here, we should have Ulysses is a brown mackerel cat. And we need to head to our terminal to do this. So we've actually stood up an object. If I go back to my file and look at it, I've stood up a cat object, in fact, 3. And if I python cat sandbox.py, I see that Ulysses is in fact a brown mackerel cat. Now we can do this for our other 2 cats. And if we do this, we should see that they are in fact distinct cats. So if we print f, Bert.name is a Bert.fur color, Bert.pattern, cat, period, so we can tell our sentences apart. Print Scoop.name is a Scoop.fur color, scoop dot pattern cat question mark? I mean, they are, but for sake of argument. So then if we go back to our terminal, we should be able to say Python, cat, sandbox, and see all our cats as distinct entities. And we do. Ulysses is a brown macro cat, Bert is an orange tabby cat, and Scoop is a black and white calico cat? Simple enough, right? But if I put these side by side, we can see exactly what we were just doing. We can see on my left-hand pane the code that we were using to call each of these properties, and on the right hand, we can see how we reused the same object with different self-knowledges in order for us to be able to distinguish between cats. So creating objects like this, like we saw with our last lab with Robbie the robot, we're able to see that small changes in our programming habits, in this case by creating objects instead of just creating these cats independently by using a function, can save us some time and, more importantly, can make our code even more economical. And we'll see those couple of additional powerful things we can do in future videos this week. But I want to leave it here as the idea that when we create an object, we need a couple of minimum things. First of all, we need to create a classification for it. So in this case, class cat. The other thing we need is we need to create a constructor that allows us to specify very particular elements that allow us to differentiate our objects from one another. This will become especially important as we make our cats more complex and as we make more of them in videos to come.